What is up, everybody? My name is Kshitij and welcome to the channel. Now in this video I'll be sharing my experience of getting a master's degree in science in embedded systems here in the Netherlands. Now this video is divided into 5 parts, which you will find down below in the video seeker slider thing. So let's get started. So first things first, motivation. Now motivation is a rather important driver to get things done. So what was my motivation behind pursuing the master's degree in embedded systems? So a bit of background: I was born and brought up in Mumbai, Thane actually, which is more or less Mumbai, and I completed my bachelor's in computer engineering back in 2016 from the not prestigious at all University of Mumbai. And here's the thing about University of Mumbai: it has a lot of different colleges, or as people around the world would like to say, satellite campuses. And my college was on the outskirts of the outskirts. And if you're asking me which college or how was the college, then please, let's not get into that. But again, that was the first motivation to get better education from world-class professors who are solving some nice real-world problems that actually make a difference. And the amount of things you get to learn from these professors is really crazy. That's a huge amount of knowledge flow. And secondly, I worked on a lot of projects when it came to embedded systems during my bachelor's, because gaining entry-level experience in embedded systems was really easy. And it still is. There's a lot of data available online, and getting started with embedded hardware or software, it's not that expensive, even if you are a student. And if you are in one of these engineering institutes, then these engineering institutes also have some sort of side workshops or seminars that can teach you these sorts of things. So I completed my bachelor's in 2016, and I was 21 then. So from 2016 to 2018, I worked with a few startups because, I was quite certain that I did not want to join a big company. So I worked with a few startups, and two of which I was the founding or the co-founding member. One of the most interesting ones, and one of the daring projects I ever worked on, was in AutoNext. And the project was to make a prototype of an electric tractor, actually a huge sized electric tractor. And I had some interest in electric vehicles back then, and I was ready to explore where embedded systems and electric vehicles come together in the picture. So AutoNext was actually the first company which actually came up with a prototype for an electric vehicle with which we can actually plow and farm on Indian soil, and we were the first company to ever do that in India. So basically, there were a lot of such crazy projects that I worked on, and after finishing these projects, there was this one feeling which I always had, that there was always something in terms of the software robustness or the hardware robustness that could have been done in a better way. And there was a point where you were just completing more and more projects, more and more tasks, than making mistakes and actually learning more. So it was clear for me then that the master's was one of the ways ahead to learn more and make some robust embedded systems that can actually work in most of the scenarios they are implemented to be executed on and worked on. Now, why did I choose the Netherlands to pursue the master's? The simple answer being the type of courses and the structure of the master's. That is what I was specifically looking for. And there are 3 such universities here in the Netherlands that offer this course titled as Masters of Science in Embedded Systems. And I got accepted to the TU Eindhoven, or as the Dutch say, Technische Universiteit Eindhoven, or in English, Eindhoven University of Technology, which is well located in the Dutch city of Eindhoven, which is in the south of the Netherlands. And the courses offered here provided a nice blend of both theory and practical knowledge at the same time. But before we actually take a deep dive into the courses, which is in the later part of the video, a few things about the Dutch and the Netherlands. Now, there is an old saying which goes by, God created the world, but the Dutch made the Netherlands. Now, I'm not sure about the part where it says God created the world, but I'm fully certain or completely certain about the fact that the Dutch created the Netherlands. Now, I have lived with the Dutch for more than 2 years now, and what I can definitely say is these people are really freaking cool. Now, most of the population speaks English, so language won't be a big barrier, but learning Dutch is really not that hard. And so let's say tulips, canals, cities with bike lanes and historical architecture make the Netherlands super pretty. A few traits of the Dutch include being effectively thrift, spending wisely, getting shit done without compromising quality. These are the things I really find interesting about the Dutch. Well, I could go on and on, but that's not the point of this video. So moving on to the next part, the video is to talk about admission requirements, fees and expenses. So let me start by saying to get an admission, GRE is not required. Relieved to hear that? Well, so was I. Now, I had also appeared for GRE, but well, I'm not really good at taking these tests. So that is one of the major differences between US universities and the universities over here in the Netherlands, that GRE is majorly not required. So you basically need 3 to 4 things: a good pointer or good grades in your bachelor's, a TOEFL score, and the other 2 things is a statement of purpose and the letter of recommendation, which are the standard things that any university asks for. But what I think really matters is good grades in bachelor's, or on the other end, I think it also doesn't matter to such a great extent, because if you have quite a balanced profile where you have done some really nice projects or did internships at some top universities in your company, worked with some really nice professors, then I strongly believe that the whole profile is generally factored in. And to get an idea of how much you need in your bachelor's on a 10-point scale, you need to visit the university website, because things and the requirements keep on changing. So just you can visit the TU Eindhoven website and go to the admission requirements section. That would be the most precise way to do that, depending on when you are watching this video. But even if the website mentions that, let's say for example, you need 8 out of 10 in your bachelor's as the final grade, and if you don't have an 8, I would still very highly recommend you to apply. Just apply. And it is not for you to decide whether you will be getting the seat or getting the admission or not. It's for the admissions committee to decide, like, hey, this guy has let's say 7 out of 10, not 8, but he has worked on some really nice projects. Let's give this guy a chance. And for example, this guy, I did not have an 8, but maybe the requirements were also different back then in 2018 when I had applied. So long story short, if you don't have the required things or the required grades, just apply. So coming to the fees, for my first year, I paid 15,000 euros, and for second year, I paid 16,000 euros, and the total is 31,000 euros. And apart from the fees, you need to look into rent, which is somewhere around 400 to 700 euros a month. Food, as well, somewhere around 150 to 200 euros, depends how rich you are, and if you like to cook 5 times a week and eat the 2 days outside at a fine dine restaurant and things like that. Then you need health and travel insurance, which is somewhere around 40 to 50 euros a month. And there's another thing called as water and garbage collection tax here in the Netherlands, and that is somewhere around 150 to maybe 250 euros a year. So that was it when it comes to the expenses. Now I found a nice internship right since the first month of my master's, so I was able to finance my rent and a few expenses with an internship. So throughout the 2 years of the master's, I worked in this company, and that was properly an embedded systems internship. You had to design circuits, you had to integrate systems, you had to write code. And many a times what I felt was like one fine, let's say for example, Monday morning I was working on this course at the university, and let's say Tuesday I went to the company for an internship. It was so synchronized that the things that I learned in the course, I was able to directly apply them on the internship projects. So the courses are really, really up to date with the industry requirements. That is what I can say for sure. But what I would also like to emphasize is that the courses are not really easy to pass. You really need a lot of focus. So doing an internship throughout the 2 years and also doing courses is rather tough. And not many of my friends, well actually none of my friends did that. I was the only one who did that, because probably my friends are super rich. I don't know that. Maybe they don't make it appear like that. So yeah. Now let us talk about the courses you will have to take in order to graduate. Now there are 4 specialization streams which the Masters of Science in Embedded Systems program offers. The first one being embedded software, the second one being embedded networking, third one being cyber-physical systems, the fourth one being systems on chip. And you can read about these 4 specialization streams in this link, which would appear somewhere over here in the video. And all the courses can be classified into 3 types. So there are 3 types of courses, no matter which specialization stream you take. So the first one being core courses, and these are supposed to be the most difficult ones, and these are mandatory courses. So no matter which specialization stream you choose, you have to take this course in order to graduate. The second type of the course is a stream mandatory course. So let's say you take embedded software or cyber physical systems. So these stream mandatory courses are specifically required if you take this particular stream. And the third type is stream elective, and you get to choose from several options. That, let's say in cyber physical systems there are like 5 courses related to cyber physical systems, and you can choose to do either 2 or 3 courses depending on the number of credits you have to gain. So one academic year is divided into 4 quartiles of 2.5 months each, and that's different as compared to the 5 to 6 months semester system, where you have 2 semesters in a year. But here in TU Eindhoven and the other universities, mostly in the Netherlands, you have 4 quartiles of 2.5 to 3 months. So now think about it. That means in 2.5 months, on an average, a student takes 3 courses. That means you have to learn 3 different courses, 3 different tool chains, languages, assignments, practicals, coursework, writing reports, and all those things. So in my experience, it was a rather steeper learning curve, and that requires a lot of focus and sitting in the library and studying in the library with your friends for like 8 hours, 10 hours, 12 hours a day. I remember the university had a really nice library, and there was these things called as study cells, where let's say 4 to 8 students can sit, and they can connect a projector to their laptop and discuss the assignments and all those things. Now, we used to generally book these study cells for a long period of time throughout the day, because you actually need to sit over there with your friends and dedicate and focus and come up with the solutions to the questions of the assignments, and then actually document those solutions with proper scientific reasoning. And if the professor thinks that that is 100% correct reasoning, that is the only point in time where you actually pass that particular assignment. So that is how it was with the 12 courses I took in the first year. And it was okay to fail. I have no shame in expressing the fact that I did fail a few courses. So it was just a steeper learning curve. And now coming to the second year is rather different. So the second year is split into two things. First one being the internship, which goes on for like 3 months, and the second one being a thesis, a graduation project that goes on for like 9 months at least. Probably you can also finish it earlier if you are super smart and then you come up with some really nice idea. Because when it comes to your graduation project or your thesis, the professors, depending on the research group they are in, they expect you to come up with something new, probably some sort of algorithm or a combination of several research projects that have been already done at the university or some other universities in the world. So the professors actually motivate you and guide you throughout a proper research process of coming up with something new, or rather combination of things. And the output is you have to write a report, might be a long report, or a standard research paper, which can be let's say for example an IEEE research paper, which is 12 pages. So that should be the output of your thesis. So what I can say is, or what I need to say is, research work is required to graduate, and that is mostly the case with TUs, or the technical universities here in Europe. There are also other universities like applied sciences which have slightly different requirements. So if you are applying for a TU university, you need to understand things might get theoretical at times. You are dealing with equations, you are dealing with formulae and all those things, and it might get theoretical. So let us talk about the job prospects after you have completed your master's in embedded systems. Now, the Netherlands has a rather rich history when it comes to software, and a majority of the part when it comes to embedded systems is software, because, well, once when you have designed the hardware, your hardware design is complete, the software is the real thing. Because you could write some really shit software and make the hardware consume a lot of power. So with embedded software, you can actually do some really nice optimizations for the processor to consume less power, avoid deadlocks and things like that. So, and if you're talking about software and the relationship with software and the Netherlands, so let's say Python, for example. The language of Python, the programming language of Python, originates here in the Netherlands at the CWI, Center of Wiskunde and Informatica in Amsterdam. Edgar Dijkstra was Dutch. Dijkstra's shortest path routing algorithm, Edgar Dijkstra, the guy who came up with that particular algorithm and many more things, like semaphores and things like that. And he actually worked at TU Eindhoven long time ago. So Eindhoven is basically like the technical hub of the Netherlands, and companies like Philips are headquartered here in Eindhoven. Philips actually started, I think so, somewhere in the late 1800s in Eindhoven. And there are also a lot of companies like ASML, there is Bosch, there is Daft Trucks, and also a lot of startups who require a lot of embedded systems personnel and embedded systems engineer, both on the engineering front and on the research front. So there is also this nice sweet spot between research and engineering. So let's say scientists do the research and engineers do the building up and engineering thing. But there's also this sweet spot in between called as a research engineer, which is my job at the moment. So I'm more or less like an embedded systems research engineer working at a company over here. So there are lots of embedded systems companies, at least in Eindhoven and also in the rest of the Netherlands. Now I can't say for the rest of the Europe because, well, I've not explored most of it yet. But we can also talk about student teams and these are student teams inside the university. There are lots of student teams like URE, which is short for University Racing Eindhoven. Then there is In Motion, which have some really cool cars. And then there is Spike, which they made an electric bike and they took it around the world. Then there's also the solar team Eindhoven. They make some really nice solar cars. And there's one which I really like and which I'm also a part of. It's called as Falcon Electric Aviation. I lead the electric engineers and the embedded systems team over there. We are working on powertrain systems for aviation. So we actually have a Cessna F-150, and it's a student team that owns a plane, and we are converting it to electric. So there is a lot of correlation between embedded systems and electric vehicles. And so the point being, these student teams also become startups. So there is lots of scope when you join a particular student team, and you can actually become a startup, and that probably takes a lot of time. So the whole point being, your location in this world actually matters, because if you are in a location like this, then you are bound to find a lot of like-minded people who can push you forward in the right direction wherever you are headed. So long story short, if you feel that you are remotely talented and driven, then there are loads of opportunities here. And many a time, if you pursue your thesis in a particular company, they offer you a position based on how you have worked for the period of 9 to 10 months in their company. So finding an embedded systems job in the Netherlands is not really hard, but that will also depend on the time and the circumstances and how the economy is doing. But if you are really proactive and you really like to communicate well with people, then finding an embedded systems job is not that hard. I know for a fact that a lot of my friends who pursued the masters got a job within the first 3 months after graduating. And the Netherlands provides a zoekjaar visa, zoek meaning search and jaar means year. So there's a job search year visa, which is of duration 1 year. So after you graduate, you can actually apply for that visa, and then you get 1 whole year to look for jobs. Now that is about it for this video. Now if you would like to see more content like this when it comes to embedded systems or professional embedded systems engineers, and especially pursuing embedded systems and courses, then let me know in the comments below. And if you like this video, then you know what to do. And if you are not subscribed, then well, again, you know what to do. So see you in the next one.